Hi, Dr. Melillo. I'm Ariel. My Bio 202 model project topic is pulmonary ventilation. Lucky for me, we just took a big exam on this topic, so I'm already pretty familiar with it. Pulmonary ventilation is just a fancy term for breathing, or inhaling and exhaling. The reason why we have to inhale and exhale is because Earth's atmosphere is compressing on our bodies and changing pressures within us constantly. This is called atmospheric pressure. Basically, the air and the pressure in our lungs are always changing because they are continuously cycling between high and low atmospheric pressure. As we all know, air is a gas. It's composed of many different types of gases, and with gases comes their own laws they have to abide by. A gas law that pertains to pulmonary ventilation is Boyle's law. This law states that pressure and volume are inversely proportional, which just means that when one goes up, the other goes down. So this relates to pulmonary ventilation because when the volume in the lungs increases, the pressure decreases, so the air from outside our body flows in, or we inhale. The opposite is true as well. When the volume of the lungs decreases, the pressure increases, making the air in our lungs want to leave or exhale the body. Since we already talked about atmospheric pressure, now we can talk about intrapulmonary pressure. Intrapulmonary pressure can also be referred to as intraalveolar pressure because it's pretty much exactly that, the pressure inside our alveoli. When we relax and are breathing quietly, the difference between atmospheric pressure and intrapulmonary pressure is relatively small. It's basically the difference between pressures when we inhale and exhale. So when we inhale, the intrapulmonary pressure drops to about -1 millimeter mercury, and when we exhale, it goes up to about 1 millimeter mercury. Intrapleural pressure is the same kind of scenario, except it's the pressure that's in the pleural cavity, which is the space that surrounds our lungs. So when the intrapulmonary pressure increases, the intrapleural pressure increases as well, but on a greater scale. When we inhale, the intrapleural pressure starts at about -3 millimeter mercury and drops to about -6 millimeter mercury. And then when we exhale, it goes back up to around -3 millimeter mercury. The tidal volume is the amount of air we move into or out of our lungs during a single respiratory cycle. Now we can talk about the actual mechanics of breathing and what causes the respiratory cycle to start. We start with inhalation, which is caused by the diaphragm, or the muscle that's directly underneath the lungs. The phrenic nerve, located in the cervical plexus, where the C3 and C5 spinal nerves connect together to form the phrenic nerve, provides innervation to the diaphragm, which basically means that the phrenic nerve uses acetylcholine to send a signal to the diaphragm to tell it to contract so we can take a breath in. Subconsciously, when we go to take a breath, what causes us to take air into our lungs is the diaphragm contracting. The diaphragm is originally in kind of a curved shape, so when it contracts, it actually lowers or flattens itself, which gives our lungs a space to expand and take the air in from the outside. The external intercostal muscles also help with inhalation because when they contract, they lift the rib cage, which gives the lungs up to 25% more space to take air in. It takes no muscles to exhale on a normal quiet breathing basis. So once the inhalation muscles relax, the elastic components of the lungs recoil and return back to their original positions. This is called elastic rebound. And that's all. Thank you so much for listening.